Hello dear students, in this session we will discuss how to calculate acceleration and reaction force between the blocks when two or more blocks are in contact. Okay, so before that I would like to solve a problem, okay, which is very similar to Atwood machine that we have solved. Okay, in the case of Atwood machine, if you remember, in the case of Atwood machine there was a pulley and there were two masses m1 and m2 were hung like this. Okay, and in this case we calculated the tension in the string and the acceleration. Okay, since this was the same string, tension was same, and we got tension is equal to 2 m1 m2g divided by m1 plus m2, and acceleration is equal to m2 minus m1 m2 minus m1 into g divided by m1 plus m2. These were the two equations for acceleration and tension. Here what we had considered, m2 minus m1 you will get if m2 is greater than m1. Okay, now very similar to this, I'd like to solve a problem. Okay, this situation you can also do it in order to check your understanding. So here in this situation, what you have to do, you have to calculate acceleration of the blocks and the tension in the string. So this is your problem. You can pause the video and you can calculate. What you have to do, you have to write free body diagrams. Okay, say this is m1, say this is m1, this is m2. You have to write free body diagrams for m1 and m2. Write the equations, write the equation for acceleration and tension. You can pause the video, try it, okay, then continue. Okay, I'll also be doing. Now here, so what we have to do, we have to write free body diagrams for m1 and m2. Okay, on m1, which are all the two forces acting? Now what happens here, what is, okay, here, say this is, unless specified, it is a smooth surface, correct? Now the surface is smooth, and this mass, these two masses are moving with an acceleration a, correct? Now, so here weight of this m2 is responsible for acceleration, because here on m1 what happens, weight of m1 it gets cancelled with the normal reaction. So therefore only tension in the string is responsible for motion of m1. But what about m2? There is a weight acting on m2, gravitational force mg, and tension in the upward direction, because tension is always away from the body or towards the support. We know what is the direction of tension. Now if I write a free body diagram of m1, the force of tension is the only force responsible for acceleration. Correct? Now this is the free body diagram for m1. Other two forces are there. One is m1g, other is normal reaction. They get cancelled. And m1 is not moving along the vertical, so we don't have to worry about it. Okay. How about free body diagram of m2? On m2, m2g is acting downwards. Okay, and tension is acting upwards. Acceleration is downwards. So therefore, which is bigger? m2g is bigger. So I write an equation, m2g minus t. So this is the net force, is equal to m2a. This is one equation. Here, F is equal to m into a. Force, only force acting is tension, equal to m1 into a. So we got equation for tension. We got one more equation. We'll substitute the value of tension here. So what happens? M2g minus m1a is equal to m2a. Correct now? So if I move this m1a to the RHS, then what happens? M2g will be equal to m1a plus m2a. A is common. So what happens? m1 plus m2 into a. So therefore acceleration is equal to m2g divided by m1 plus m2. Now here I had taught you how to write the equation for acceleration directly. Unbalanced force divided by total masses. Unbalanced force divided by total masses. Here you see only unbalanced force which is responsible for acceleration is m2g. Correct na? In the previous case, in the case of Atwood machines, there were two unbalanced forces, m1g m2g. That is why what happened? m2g minus m1g. Correct now? But here unbalanced force is only one, m2g. So therefore, what is the answer for acceleration? m2g divided by m1 plus m2. In this way, you can write the equation directly also. Now what to do? We got the equation for acceleration. Then what is tension? For tension we have written equation. Tension equal to m1 into a. Tension is equal to m1 into a. A means this, right? So therefore what happens? Tension is equal to m1 m2g divided by m1 plus m2. m1 m2g divided by m1 plus m2. Now we should understand what is the difference between this problem, okay, this problem, and the Atwood's machine. In Atwood's machine, what is the equation for tension? 2 into m1 m2g divided by m1 plus m2. In the given problem, this 2 is not there. Okay, because string is being pulled, okay, in only one direction. Okay, here 2 are there, na, 2 masses are there. So that 2 will come. Okay, in the given problem here, that 2 will not come. Only m1g is, so that is why 1 m1 m2g divided by m1 plus m2. In this way, you can remember these equations for acceleration and tension. Now we will discuss how to calculate acceleration and reaction force when blocks are in contact. Okay, when blocks are in contact. So what is this? We will see. Say there is a smooth surface, and here there are two masses. Say this mass is m1, and there is one more mass here. This is m2. Say some force F is being applied on the masses m1 and m2. So because of the force, since this surface is smooth, okay, means frictionless, these masses, they get accelerated. Say the acceleration is a. Okay, now we will write free body diagram of m1. Okay, on m1, which are all the forces acting? One force acting is F. That is very clear. Now you see, this m2 is not easily allowing this m1 to go forward, correct now? So between the surfaces here, there is a reaction force. That reaction force, I represent it as R12. Okay, R12 stands for reaction force between m1 and m2. Okay, that reaction force is not allowing m1 to go easily. So what does it mean? That reaction force is acting in the opposite direction. So these two forces are responsible for acceleration. m1 is accelerating forward. So therefore, which is the bigger force? F is the bigger force. F minus R12 will be equal to m1 into A. This is equation number 1. Now, what about free body diagram of m2? Free body diagram of m2. On m2, only force acting is R12. Correct now? Because you applied F on m1. On m2, which force is acting? It is R12, reaction force is acting. So this reaction force is responsible for motion of m2. So R12 acts on m2 in the opposite direction. Like in the case of string also we have seen. With respect to the block, tension was upward. With respect to the ceiling, tension was downward. Correct now? In the same way, you have to remember the direction for reaction force. Okay. Now for m1, R12 is not allowing to move freely. Okay, but for as far as m2 is concerned, R12 is responsible for motion of m2 because F is being acted on m1. On m2, which force is acting? R12, reaction force is acting. So R12 is responsible for acceleration. So therefore F is equal to reaction force equal to m into A. Okay, these are the two equations. Now therefore we can write the reaction force. We got an equation for reaction force straight away. It is m2 into A. m2 into A. For masses towards the right, okay, into A. Then what about acceleration? Equation for acceleration. Here I'll write F minus R12 means m2A. m2A is equal to m1A. Correct now? So F equal to m1A plus m2A. So m1 plus m2 into A. So acceleration is equal to force divided by total masses. Force divided by total masses. This we knew it, but we derived it using free body diagram. Acceleration. Reaction force is m2A. Now how to generalize this? Say for example, now you will be able to answer my questions very easily. Okay. Say there is a mass m1, there is a mass m2, there is a mass m3, there is a mass m4. Okay, now force is being applied in this direction. Here there is a force, reaction force R12. Here there is a reaction force R23. Here there is a reaction force R34. Okay, R34. And the system is being accelerated with an acceleration A. Now, if you look at previous situation, what is R12 equal to masses towards right, okay, into acceleration m2 into A. So now here, what is R34? See, this is very easy to write. R34 is equal to m4 into A. M4 into A. Okay, then what is R23? R23 is equal to R23 has to push M3 and M4, correct? Now, therefore, what happens? M3 plus M4 into A. R23 equal to M3 plus M4 into A. Then what about R12? So reaction force between M1 and M2, this R12 has to push all these three masses M1, M2 and M3, correct? Now, therefore, M2 plus M3 plus M4 into A. Correct now? Then what will be the equation for acceleration? Now F, what F has to do? What is F? F has to push M1, M2, M3, M4. Now what happens? M1 plus M2 plus M3 plus M4 into A. Correct now? Or acceleration equal to force divided by total masses. F divided by M1 plus M2 plus M3 plus M4. So this is half. You can write equations for acceleration and reaction force directly without writing free body diagrams. Okay, first you need to know how to write. Okay, if the direction of force, changes, okay, if the direction of force changes, then what happens? If you apply force in this direction, then R34 will be equal to M1 plus M2 plus M3 into A. Okay, hope you can understand. Hope you understood this calculation also in this problem, how to calculate acceleration and tension. Okay, this blocks in contact is also a very important concept as far as loss of motion is concerned. We will come up with some problems in the next session. Hope you understood this. Thank you very much.